Okay, welcome everybody to this third webinar in our mini series of best practice webinars. This one is on best practices in DIH Technology Services, and my name is Thomas Vöguele. I'm from DFKI in Bremen, and today we will have three guests: Hans Bieland from Sintef, Mikko Siuko from VTT, and Ladislav Vargovic from TUKE. These webinars are part of the RIMA project, and those of you who have been in the last two webinars may already know this setup. So today we will talk about the technology services, which are together with the ecosystem and the business services, some of the main services that you can offer as a DIH. And the purpose of this talk is to give an overview of these services and then to also demonstrate some best practice examples which show how it can be done and who has done a good job on this. We'll look today at technology services, strategic RDI, contract research, technical support on scale-up, provision of technical infrastructure, and testing and validation. So the first three services are kind of linked together. And you can see from this slide here, from this graph, that we're talking at services at different time schedules, from long-term to short-term projects, and also at different technology readiness levels, TRLs. You can see that the strategic RDI is at a low TRL, most long-term running, and technical support and scale up is at the upper end. Actually, this slide should look probably more like this, because of course, during the projects that you do in these categories, the TRL usually of a product or of a prototype will increase. So let's start with strategic RDI. What is strategic RDI? Really, strategic RDI is about long-term collaborations. So we're talking about up to 10 years. I mean, 2 years is the minimum, but it's more likely to be much longer. 10 years, 8 years, 10 years, something in that range. So this is valid for, or the target audiences here are all SMEs, but also industry and public organizations. In that sense, these services are a bit different from the services we talked about in the last webinars, which were mostly focused on SMEs. Here we're also looking at industry and public organizations. And in strategic RDI, the outcome of projects run here will be on a low TRL mostly. So it's about methods, it's about a proof of concepts, and it's to advance key technology areas like the ones that are relevant to robotics. You see on the left, mechatronics, human-robot interaction, perception, cognition, and so on. So these technology areas you want to boost with your strategic RDI. And for the customer, which is a company or public organization or an SME, it means that they can stay more competitive, and it supports their long-term product strategy. For the DIH or the RTO, the Research and Technology Organization involved in the DIH and that offers these services, it ensures that the DIH stays at the cutting edge of research, and also it increases the visibility of the DIH and the RTO in the scientific and the industrial community. As I said already, it's a long-term endeavor, so you need money for this, and so it's a good choice to go for third-party funding, which can be regional, national, or European. You can use, and this is a good idea, to use frameworks or to be part of a framework like a virtual research center or a center of excellence or an innovation cluster. Here in Germany, these type of frameworks are becoming very popular. So they are usually designed to last for longer times and to provide funding and also the organizational framework that enables this strategic RDI. But you have to keep in mind that especially smaller companies have to make a profit and cannot just go with third-party funding or on a long term. So you also should offer shorter-term spin-out projects to enable them to make a profit in between and to create products before this framework and this program is ended. And last but not least, it's important to seek cooperation outside the DIH, either with EU programs, strategic EU programs, or even international collaborations. One example that we want to show how this can be done comes from Finland, from Sintef. And I want to hand over to Hans to tell us something about the exposed aquaculture operations.
Thank you, Thomas. It's Norway.
Oh, did I say Finland? Sorry.
Yeah, that's fine.
Yeah, Norway, of course.
I know, you know. Hello, everybody. I'm happy to be here to talk about our experiences with what you can call a virtual research center that I'm heading, the exposed aquaculture operations. Do I have control over the presentation, Tom?
No, I think I.
Okay, yeah.
Slide.
So just first, I'll give you some context behind our research center. And we are working on aquaculture technology to support the safe and efficient and environmentally friendly fish farming for the salmon industry. And we are working for these, of course. This is a typical current production system. It's a large, flexible cage in the ocean. And of course, we have to make sure that the technology provides a safe working environment for these. And next slide, please. And obviously these, which really makes this something different from what we might compare this to oil and gas, for example, where we don't have these individuals that we have to take care of, obviously. Next, yeah. The colors are slightly off, but this is the current production. So it's based on open, flexible cages, and to kind of illustrate the amount of exposure that we see, we have some kind of sheltering at current production sites, but there is a potential in using current technology also for more exposed waters. Next, please. And then there is a large interest in also utilizing land-based or also closed containment systems at sea, which is not the focus of our research center, but it is a focus of Sintef and the Norwegian aquaculture industry. And next, please. But then there are a lot of new concepts maturing for larger, stiffer cages and cage structures that can be utilized for even more exposure. Next, please. And that is the context of our research center. So both utilizing the experiences of operations and the challenges with them in current cage culture, and also laying the ground for future use of more exposed waters. Next. So that's the background for our research center. It's a funding scheme by the Research Council of Norway, which allows us to work long-term, as Thomas talked about, for a set of challenges and opportunities that each individual partner is not able to fulfill themselves. So with us here, we have obviously some research partners, as Sintef we are the host institute, and we have Institute of Marine Research on the biology side, and also the Norwegian University of Science and Technology. And then on the user side, we have Movi, Cermaq, and SalMar, which are some of the largest salmon producers in the world. And they have slightly different strategies when it comes to utilizing exposed sites. And then we have service providers, at the moment only AQS, but a lot of technology providers, engineering and certification providers. And much as it is research at the center of such a center, I think the partners would say that equally it's important how they utilize this as an arena to discuss with their customers, their competitors and collaborators, to gain a better understanding of what the needs are. Next, please. The colors are off, but
sorry.
We early on identified the need to focus on the operations, because it's no problem in designing anything that is in the sea, just as long as you're willing to pay for it. But having something there that is cost efficient and also something that you can operate is the key. And then we have you can take next, please. Oh, that's better. So we have to combine in such a center both the technical, but also some other key factors to succeed in this. And obviously we could have several research projects on vessels alone, and autonomy and monitoring structures, safety and fish. But the real strength of having such a center is our ability to combine those, because a vessel needs to be designed in ways that it doesn't harm the fish and it needs to be safe, and it needs to have a proper interaction with the structures, for example. Yeah, next, please. And this, I'm sorry about the colors, but this is another way of looking at it. So if we have the research areas of the center at its core, we have several projects defined, both internal to the research center, but also several associated projects that are initiated by partners, one or several partners, with PhDs, for example, or not. It can vary from very fundamental research to more industrial collaborations. Next, please. What also such a research center provides is the access to various types of research methods. And having the technology providers, for example, being able to test their equipment easily at relevant customers, and getting that, not only getting the data from that, but also the feedback from their customers on how their technology adapts, is very important. Next, please. We also conduct lots of model testing at Sintef and elsewhere, which is also part of that research methods that we provide in such a center. Next, please. And which might be most of relevance to your project here is the need that we see of automated inspection and preventive maintenance, for example. The reason why I include this soccer field is the size of each individual net is approximately one soccer field in size. So that means that we have to find some good ways of automating and navigating those kinds of equipment to improve inspection, for example. Next, please. And these are some examples of where we do fundamental research within the core of the research center, either through projects in the center or at each individual partners. We are able to see that there are innovations that are happening due to the work done in the center. Here are some examples where, for example, one of the fish farmers are establishing a new test facility outside of Trondheim, where I am located. We have vessel designers designing boats that are adapted to exposed sea. We have products that are tested and verified. We have new guides and regulation, as well as new robot arms that are adapted to the needs of the aquaculture industry. So the final slide, please. Just to kind of try to sum up, a research center as this does provide, it has an aim to develop and deliver on research. Obviously, we are measured on how many publications and how many PhDs that we are producing, but we are also measured on innovations that the center and the center partners are generating. And to succeed in that, it's much more than just carrying out the research. It is very much about bringing people and organizations together to get kind of get rid of the bottlenecks and I, as a center director, I'm measured on how well all of my partners succeed in this. And in addition to the center partners, we bring in other industries, government. We try to make a dialogue with other stakeholders as well, which is important. Yeah. So I hope this was somewhat useful for the discussion that you are having in how to provide services like this. Thank you.
Yes, Hans, thank you very much for this very interesting presentation. Sorry for mixing up Finland and Norway, of course, from the west coast of Norway. Okay, so let's continue with the next topic, which is the contract research. While strategic RDI is a long-term issue, contract research is much shorter term. It's 3 to 4 years and maybe even shorter projects. And what we're talking here about is developing prototypes at a high TRL. Research prototypes still, but at much higher TRL than during the strategic RDI. The framework in which this is done is usually industry-driven research and development projects, but it can also be just a consultancy service. Then it's probably only for a really short project. Companies that do not have research capacities or that need, on a short-term notice, that need some short-term R&D results, they often resolve to contract research. So the client is actually giving money to the DIH or to the RTO that runs this contract research. And for the client, this has the advantage that he gets state-of-the-art research for a competitive rate, because most RTOs are cheaper than industrial competitors. For the DIH and for the RTO, it has the advantage that they receive industry money, which sometimes is needed to co-fund third-party funding, which is not fully funded, 100% funded. So these industry money is an important factor, but it's also important to get in touch with industry and to get contacts with industry and an insight in the needs of industry, because these are essentially also the clients and customers needed for third-party funded research. The disadvantage of contract research is that the IPR typically stays fully with the client, so it probably can be used by the research organization to do some dissemination, but sometimes even that is very difficult. So for PhD students, it's a difficult issue. Can they publish or can't they publish? And another pitfall here is also that if you rely a lot on contract research, then your research, of course, will be very market driven. So you will not go for the long-term vision, but for the short-term, objectives. And so if these change, if the market changes, then your research is probably not interesting anymore. And also it's difficult to get beyond the crowd and to be on the cutting edge of research with this type of contract research. To be able to do contract research, you first have to establish a competence center or a unit in your organization that is able to do it, because you need a certain infrastructure, you need know-how, and you need overall a kind of a company culture to be able to do this type of contract research. For example, universities often have, for universities, it's sometimes not so easy to do it because they are used to different working paradigms. And it's also not so easy for the students and PhD students and researchers to work on contract research projects. It's a different culture, but it's definitely worth it. The companies that will give you contracts are often large companies, and these are the ones that will pay with their own funds because they do have them. If you work together or for SMEs, it's better probably to acquire third-party funding. You can go there to special SME programs like the EU SME tool. I don't know how it's called in the new framework program, but there are special funding tools that enable research organizations to cooperate with SMEs and to get paid by third party for the research they do for SMEs. One thing, it's very important in this contract research that you set the project right. That so the first thing is that you make a good estimate of the project volume. And here you really have to pay attention that you have to consider a safety margin. Contract research is different from third-party funded research, and that there is a customer, and this customer wants to get value for money, and if you don't deliver, then you're in trouble. And so this may require extra efforts, which you have to factor in right from the beginning. So putting together the project budget is different from a normal research project, if you want. And then it's very important to discuss a lot with the client before you start the project and before you set out the work program. So you get you can develop a clear and joint understanding of the goals and strategy of the project. And you have to take care that the project is well targeted and well defined. And there is no, you have to take care that there's not too much possibility for the client to change plan in the middle. On the other hand, you have to stay flexible in R&D, because it doesn't make sense to go for a goal that was fixed at the beginning, and then your customer, your client, is not interested in that anymore at the end of the project. So especially for projects that go a bit longer, that have a longer duration, it's important to have flexible project management there, incremental, interactive, and agile project management to change things if necessary. You should make sure that the results of such a project can be commercialized in a timely manner, because you're working with companies and they want to make a profit and they don't want to wait for too long time to be able to sell, to go into product development. So it is probably a good idea to set up something like a minimum viable product, to define a minimum viable product, and to set up early stage demos, so that you can deliver something right at an early stage already, and you can also change plans if needed, or modify plans if needed within the framework of your budget and project, of course. And last but not least, if needed, you should integrate other companies into your consortium, companies like system integrators that can pick up where you have to quit, or that can take over tasks that you're not able to do, like setting up or developing the research prototype, or the prototype you develop here, into a real product. As a best practice example for
one thing, we had a comment from the audience regarding the SME tool you mentioned. According to Nico, it's called the EIT Accelerator Program. Perhaps
okay,
we should mention it for interested people.
Okay, the EIT Accelerator Program. Yeah, okay. I'm sure there are several tools in the new program for specifically targeted for SMEs, as SMEs in the European Union are a very important factor, and the EU is really trying to boost SMEs. So they have all kinds of funding opportunities for SMEs specifically. So Mikko from VTT, are you ready?
Yes, I'm ready.
The presentation? Yes, and now Mikko truly is from Finland. This time I'm right. So Mikko, please, the floor is yours.
Okay, thank you very much. So, and mixing two Norwegians is not so very bad. We are very close. Yes, anyway. Okay, and Thomas, you did have a very good presentation already, so that I will put in some VTT stuff, so that VTT comes from Technical Research Center of Finland, and so that we are government owned, and my presentation is about robotic area research. And could you please, Thomas, click several times to get all the now that's it. Thanks. So that we do work on robotics, typical industrial robotics, robot-human cooperation, various special robotics, from material handling to rob cars, and control things from teleoperation to visual servoing. So that this is, now we do have in this picture, we do have boxes, but actually it is blurry area, so that all kind of mixers are possible. Next, please. And VTT today is said, this map is from 2019 anyway, and employees 2,100, about that much, a bit more perhaps, so that we are a bit growing, and turnover is 147 million euros and total budget 245 million, and it's really, as said, we are owned by Finnish government and steering of Ministry of Economic Affairs and Employment. So next slide, please. So we do have our position in Finnish system, and it is moving a bit. So that I mean that our organization is moving a bit, but anyway, we have been only government-owned technology research center all the time, and our role is at the moment under Business Finland, which is requiring our process to be more like an aiming to exports, so that more international cooperation, and that is going quite well with EU framework programs, but also so that we are working with many export industries. And next slide, please. So funding is one of the most important things for doing something, so that our research work has several sources for funding, but mostly this Finnish academy, EU-funded project, and other public research projects. They are doing public research, so that when doing contract research for companies, then we are doing something which aims more company benefits, and IPRs are better controlled, and so on. So that so the Business Finland funded joint projects are something that we do have. We do get Business Finland funding if we do have group of companies and we do have good idea. So that is possible to get Business Finland funding. I will tell that a bit more. Then share benefit project is that we do have a group of companies who are paying together, so that we are all putting some money for the research work, and companies are putting money, paying also our salaries, so that we get a kind of group program aiming to some real results. And then we might have those direct customer agreements, which means that we do research work directly for companies, so that it is kind of company specified R&D project, and that is the best one, so that then company gets full IPRs also. So next slide, please.
Okay.
So the practical, let's say that sales operations, or let's say communication with companies, it is more like a communication with companies, so that we are all the time know what companies are needing, what is going on there, and we can offer our services, and they do know what we do have offer all the time when we do have specific guys for specific companies and specific industries, so that we do have these so-called solution consultative sales. And really means that the person is every now and then contacting to customers, and they do know what is needed, and that is it. And then they find case-by-case solutions, so that whatever company is needing, we can make it a kind of tailor-made solution and tailor-made project team, and also program which fits to some of those earlier mentioned. It might be a direct project, or then a Business Finland funded project, so that salespersons for customers, and then there are salespersons for different technologies, and those experts, so that the researchers are participating to sales and planning on the project also. And also sometimes it is so that the companies are contacting to VTT to ask some research work and discussing about problems and services. So that different project models for customer needs are those contract research, so that we tailor-made the research project for one or more customers, and then companies can participate to public funded research program, something we already have, and we are offering companies participation possibility. And then if there is nice new topics, then we can start to generate a new public funded research program, and finding partners, making research plan, and generating kind of research program from zero. And next slide, please. So that couple of Business Finland funding models are presented here, so that the co-creation, so-called co-creation project, is something that is there to kind of prepare project. Co-innovation is the real, let's say, R&D program, but co-creation is something that we are preparing that. Funding is something like 100 kilo euros, 4 to 6 months time, and they are paying 60% of the costs, Business Finland, I mean. And their idea is that during that time, VTT, or together with companies or some other research organizations, we are developing the project, we are building up the idea, getting the companies, and making a research plan. And after that has been done, then we sell the idea to Business Finland to get more money, so that there is, like in picture, co-creation project is done by VTT or several organizations aiming to research project plan. And the next slide, please. Then co-innovation project is what is the results from the previous phase. So that if the plan what we are generating in previous phase is something that everybody are happy with, that then we may get funding from Business Finland. And it means that there is minimum 3 companies who are applying it, and VTT And all these companies may have different size projects, so that these companies do have their own projects, so that we are not sharing all the results. We are doing some, we do have common main ideas, but for company 1 we do something else, with company 2 we do something else, and company 3, so that all the companies are getting some of their own problems solved, but it has to be related to the same topic. And so that large companies, SME companies get funding for their work, and large companies, they need to use Word, but they also need to subcontract research work from smaller companies or research organizations. And all the companies need to aim to international growth. So that is because of Business Finland does have these kind of goals in their own program. But that is these things are research projects which can be, they are kind of applied science, so that we need to generate some real commercial benefit, and in that case, Business Finland is granting us so that the research organizations are getting 70% of their costs. Large companies are getting maximum 40%, and SMEs maximum 50% of their costs. And the rest of that has to get from increased sales, for example, so that VTT can sell their own research, make their own research contracts, private research contracts, so that they get the full amount, and companies need to get commercial benefits to get this money. And next slide, please. And the laboratories for robotics we do have in Tampere, Espoo, Oulu in Finland. There are a bit different robotic topics each, but we do quite a lot cooperation also. And when we do get projects like described before, we are sharing it between different offices and get kind of work share. We do have some own specialties in each city, so that we get the work shares load evenly, and also we can develop our skills better. I think that I have exceeding my time. Is it so?
Yeah, I think we should hurry up a little bit.
Okay, we could just click next slide, please. So that our idea is that we solve customers' mission impossible and find special purpose robotic solutions, because those standard solutions are solved by robotic sales guys and companies who are integrating the systems also. So that our specialist areas are sensor-based robotics, customers 3D, safety design, so on. Next slide, please. And also, at the moment, we do have interesting project about those multi-purpose robotics, Muro, which means that we do have about 13-15 companies who are interested in robotics, which can do different kind of inspection and integrated inspection things in their facility, so that they are checking that checking different things that what they can do, so that we are getting this spot robot also here so that we can, let's say, find new jobs for these kind of systems for group of companies. Next slide, please. And the virtual reality, let's say that digital twin, so-called digital twin, and different kind of teleoperation things, they are also close to our lab. We have done these kind of things and would like to apply it further. Next slide, please. Okay, sensor intelligence. Please, next slide.
Yeah.
So, thank you very much.
Thanks, Mikko. Thanks very much for this overview of Sintef's and of VTT's of VTT's capabilities in this area. Great. So we go to the next topic, which is technical support on scale up. And if you look at these little icon on the top right, you can see that in terms of TRL, I mean the main difference between this and the last two categories is that we're really talking here about demonstrators at medium to high TRL. So we are going beyond, well, we're still in the realm of the research prototype, and actually in concept testing and demonstration, which is the first subcategory of tech support on scale up, we're still talking about an academic research prototype, if you want. So that means it's a prototype that was developed using kind of the materials that are available at the institution that does it, the tools, for example, software development frameworks and so on, that are available there. And it also uses the standards for software development and hardware development that are available there. But so it's a research prototype, but it is tested and demonstrated under industry realistic conditions, which means mostly still in the RTO's own test facilities, but conditions that are very close to the real thing. And the objective of this concept, this task, is to test the new technology and to determine the key features and find maybe key flaws and repair them on time. And then even a step further and a step up in the TRL scale, we have these final steps towards commercialization. Here we really talk about a close to market prototype already. That is, it's a prototype that uses what will be used in the final product: industrial materials, software frameworks that are used, software programming languages, for example, that are used in the final thing. And also, standards have to be covered here. And this tool, this prototype is then tested in a real working environment. And this step towards commercialization may even include small serious production of parts or of the whole prototype within the RTO. So, as in contract research, of course, it's very important that you have a very close contact throughout the whole project with your client. And one thing that comes in very nicely here is exchange of personnel. So it's probably a good idea to send a researcher for a secondment to the client. We often have this, that researchers are sent to large companies to do an internship, or maybe even 1 or 2 years work there, kind of get used to that environment and see from the perspective of the client, of the company that gives you this contract, what is needed and how should it be done. This is very important to get a very close link between the industrial environment and the research environment. The project should involve all asset owners, tech suppliers, and also companies that are responsible later on for the go-to-market after the project, if your primary client is not the one who's doing this. As I said already, it's important to test it in real working environments. And the financing is often, comes often through the client company itself, or of course, there's also an idea, especially if you're talking about SMEs, you can use third-party funding, like, for example, the RIMA project. I mean, this is an example where our FSTP program gives money to small companies to really do some very testing and bringing out a product in a new environment, for example. But there are also other programs like Marie Curie ITNs, where the relationship, I mean, it's usually related more to research, but the relationship between industry and research is very close there, and you have a lot of secondments from of researchers to companies. There are also, of course, national programs that support this step in the product development. As a best practice example for this, I want to hand over to Ladislav from TUKE, and he shows us how in the Faculty of Mechanical Engineering they support the technical support on scale-up. Ladislav, the floor is yours, and yeah, we're almost out of time, but let's try to do it quick and.
Okay, thanks. I will try to be short. I will present some examples from our experience exactly on this part of development, the research. So we are starting, next slide you can. Sure. We are starting with some laboratory tested prototype, which is approved from side of functionality, basic functionality, and they are necessary to do another steps to get a commercialized product successful on the market. So first is development of prototype for the real conditions, respecting all these design and safety standards valid for its application. What we did was mainly robotics for harsh environment, for aggressive chemicals, high temperatures, and similar. So there is, in such a case, is necessary to simulate somehow these conditions. So if we know in advance the conditions in which this prototype will, or this equipment will work, so we must first study all regulation standards which are standard and requested in the customer's environment. Then important is the testing the prototype in industry realistic conditions simulated on mock-up, so-called FAT test, factory acceptance test. It's made in a factory of a producer, and that is possible to simulate some functions special for application at the customer, or some space limitations, and if the robotic equipment is using some tooling, so simulate this technological operation in real scale. Then adjustment of the prototype in close collaboration with end user to get the final commercial product. Here can be used national or EU funds for commercialization of the product. And here mainly the end user people are coming to producer or people from research and development side, and they are working together because they know better all these limitations and standards, and they, from the operation of this robot in the real environment, they know what request can arise. After that testing of product in end-user facilities in real conditions, so-called site acceptance tests, must be done straight in customer facility. It's approved by authorities from side of safety and other request of customer, mainly as we were used to work in nuclear power plant, so radiation and or in case of military application, it's a robustness of communication, security, and so on. And after that, it starts with a small batch production, but here the role of DIH is only some advisory supervision. Next, please. So here I would like to show some examples of applications of robotics in which we as a DIH were collaborating from 20 up to 80% on the development of the prototype to get a final commercially successful product. So we worked on the 3D vision, for example, from the robust communication in nuclear power plants, on security of this communication, materials for radioactive environment, mathematical modeling or stress and deformation analysis. Then briefly, on the first picture on the left side, there is a inspection robot for nuclear power plant for higher radiation, for decontamination, able to work with tooling. So we were concentrated to 3D vision and robust communication. So next one is for military purpose or for checking of internals of trains, planes, buses, trying to find some explosives like fight against terrorism using X-ray module at the end of the arm. Next one is for nuclear power plant, again robot for radioactive environment, dusty environment, using several kind of tools, good for fragmentation and such a first action in case of accident. Next one is for fragmentation of piping in time of decommissioning of nuclear power plants. So all these cases were such a kind that the first prototype needed to be sold and ready for operation at the customer site. Left down is a robot manipulator, I can say mobile, which is used for checking inspection of explosives, booby traps on chassis of cars. So again, the main point was security and robustness of communication and ability of locomotion system to go through obstacles, staircase, and so on. Next one is typical teleoperated manipulator in hot chambers, in which electronics and efficiency of gears was very important to get feeling and force feedback in the system. Next one is for cleaning of pools for storaging of spent fuel rods, cleaning for mud and really the high levels of radiation. And the last one is installed in time of installation and building of LHC accelerator in CERN in Geneva, in which we made stress analysis because the limitations of size of this robot was very strict, and it was really at the edge to reach the successful product. Next one. In this case, I would like to show one concrete example. It's a robotic equipment for fragmentation of steam generators in nuclear power plant. It was a combination of, let's say, customers. It's a RTO with high theoretical knowledge of processes in nuclear power plant, and they have got a contract for this robotic equipment. And their partner or daughter company now is Technos, this manufacturing company, but with a low experience in robotics. Its end user, its owner, asset holder of these nuclear power plants, which were under decommissioning. And we acted as a DIH, the company or institution who has experience and knowledge in robotics for this purpose. Next one. So here we can see several steps. So first was a modeling of the equipment. The blue one on the model is equipment with the two cutting modules, by which we are cutted the shell of this steam generator, plus manipulator with a robotic function, also cutting the heat exchange pipes. So here we made also help in control system in analysis of stress deformations, dynamic analysis, because here robot was working with a strong milling cutter, and it was very demanding from side of stiffness and precision. Next one. And here is the result in a nuclear power plant, first without steam generator, and on the right side there is a steam generator inside, and you can see the bench of pipes which were cutted by manipulator in a robotic mode or teleoperated mode. So it was the result with a fully functional robotic system for fragmentation of, on one side, shell of the steam generator, and also inside pipes for heat exchange. So that's all. Thank you very much.
Thank you, Ladislav. Very interesting. Very interesting. So,
thank you.
The next topic is the provision of technical infrastructure. And I will go through this quickly. So the idea here is really, I mean, this is of course related to the previous categories. That is, in the previous categories, all this technical infrastructure is already used, but of course it's also used in other for other services like in, you know, accelerator and so on services. The idea is really to provide here infrastructure to enable test before invest, to allow people or to allow customers to develop, test and demonstrate their new technologies, give a showroom, provide a showroom for these products. And I would call lab environments, or I would call the typical infrastructure that is provided by an RTO as a realistic lab environment with a low to medium TRL. So it's useful for strategic RDI, contract research, and concept design and demo. I guess for the next steps in towards product development, you need something that's outside the lab and that's even more realistic in a more of a real world environment. Technical, if you have technical infrastructure that you want to share with your DIH, or also with other DIHs or with other customers outside of your DIH, it's important to have a very clear-cut cost structure that puts down how much this will cost on a day-to-day basis, including personnel or without personnel. In most cases, you will need to include personnel because it can be this facility can't be run by the customer himself. For financing, it's a good idea to include the infrastructure, of course, in the R&D projects themselves. If this is not possible, for example, for external customers, SME startups, it's a good idea to set up a voucher system. We have talked about similar systems in the first webinar on accelerator. So it's you can give startups vouchers so that they can hand in to use your facilities. But these are only a few of the options that you can think of. Essentially, it's about marketing and selling your facilities. And of course, RIMA is a very good network to market and advertise your facilities. And I think from a European point of view, it's really a good thing to have these facilities on the market and available to many companies throughout Europe, and not only in the direct environment close to your DIH. As a best practice example, I have two small examples here. One is the GRVC robotics lab operated by University of Seville. It's a test environment for unmanned aerial vehicles. I think quite unique. They have a very high accuracy indoor tracking system, so you can actually test your software and your systems, your tools in this system, and with the ground truthing and everything. And most customers that go in there rent the facility and then test their own equipment and their own UAVs. A second example is from my own institute, the DFKI Maritime Exploration Facility or Exploration Hall. It's quite unique in Europe. It has a huge saltwater filled basin which is 8 meters deep. So you can do quite nice tests for maritime equipment. There's also other smaller tanks that can be rented, and we have developed a price schedule that customers can ask for, and we rent it out on a day-to-day basis if needed, including support staff. Yeah, so last not least, there is testing and validation. And in contrast to the previous category, this really goes into it's it is already product development, if you want. You're looking at a very high TRL here, and the idea is to get companies a possibility to go towards certifications and also high-level product demonstrations. And yeah, I guess certification is one of the main topics here. So what you need to do is to provide the possibilities to comply, to test products or close to product prototypes, and see if they are in compliance with standards and regulations. Another option is also to test, to provide independent testing of a product against competitor products as an independent test capability, if you want. The money here, of course, comes directly from the client in most cases. In some cases, you can also use third-party funding, like, for example, the RIMA FSTP. If you have a small project that fits into this slot, then you can probably get funding for this as well. I have one example here, which is the pressure chamber, also provided by DFKI. It's part of this underwater maritime test facility, And it's really quite unique system. There are not that many around in Germany. So it can simulate pressures of 600 up to 660 bar, which is 6,600 meters of depth. So you can simulate deep sea conditions, and you can test equipment, of course, just relatively small equipment up to a diameter of 40 centimeters. So sensors, cameras, electronic parts, and so on. And as a customer, you can rent the facility, and we will then do the tests for you. I mean, experienced staff will do the tests for you to your specifications, and you will get a very detailed test protocol, which you can use to support certification. We are not yet qualified as to do the certification ourselves. The certification, maybe that's something that could come up in the future, but we'll at the moment no. But you can use these protocols to go to somebody who can certify your product, and then you can sell it with a stamp on it, certified for 6,000 meters. Okay, with this, I come to the summary, and these were the categories that we looked at, the main technology services that can be provided by DIH, strategic RDI, contract research, technical support and scale-up, provision of tech infrastructure and testing and validation. And yeah, I don't have to summarize all of them. I think from top to bottom, we're going, it's kind of an increase in TRL going from the research domain to the product domain. And I think here the DIHs and the RTOs in the DIHs can really play a very important role, because this is usually, especially for smaller companies, it's very difficult to bridge that gap from the prototype, the research prototype, to the final product. Here we can really help out a lot. And with this, I want to thank you for your patience and for listening to our webinar. And I want to give back to Tom. Are there any questions?
Nothing I didn't answer yet in the chat. Nothing relevant.
Okay, then I apologize for being a little bit over time, but I hope you enjoyed it nevertheless, and I hope it was interesting. And yes, I wish you a nice rest of the day.